Hello students, welcome back to our channel. Students, in this video we are going to study a very important topic from class 12th physics chapter atoms, and this topic is Rutherford's atomic model. Rutherford did an experiment which is called Rutherford's Alphar scattering experiment. You must have heard about this experiment in class 9th and in class 11th chemistry. Yes, we are talking about the same experiment in which he took a very thin gold foil and did the experiment. So we are going to study each and every detail of that experiment. We will see the experiment, then we will see what is the meaning of this term, distance of closest approach, then the postulates of Rutherford's model of atom and the limitations of Rutherford's model of atom. So let's start. Rutherford took a very thin foil of gold, right? This is a gold foil, and what he did, he bombarded positively charged alpha particles. What is an alpha particle? If you do not know, let me tell you what is an alpha particle. An alpha particle is nothing, it is not a new particle, it is the name of the helium nucleus. What is helium? Helium is the second element after hydrogen. So the atomic number of helium is 2. That means there are 2 protons and 2 neutrons, because mass number of helium is 4. So there are 2 protons and 2 neutrons in the nucleus of helium, and 2 electrons are revolving around that nucleus. So if we remove those 2 electrons, we are left with just the nucleus of helium atom, and that nucleus is called, which is obviously He2+, doubly charged helium ion. That is the, obviously if we have removed 2 electrons from the helium atom, then it becomes He2+, and this doubly charged helium ion is called alpha particle, right? Okay, so what he did, he bombarded alpha particles on the gold foil. So what was the reason of doing this? And where did these alpha particles come from? He used a radioactive source for this. We will study about radioactivity in later chapters, in mainly the next chapter, which is nuclei. So what is radioactivity? Radioactivity is the phenomena in which some heavy nuclei emit high energy particles. So lead nucleus or bismuth nucleus, they all continuously emit high energy particles. So he took a radioactive nucleus, which is a radioactive element, because nucleus term was given by Rutherford. So at that time it was a radioactive element. So radioactive, he took a radioactive element which was continuously emitting alpha particles, and he used those alpha particles as a beam and bombarded that beam on the gold foil. So what was the logic of doing this experiment? At that time, the structure of atom was not known. Obviously, this experiment is to know the structure of the atom. So at that time, the structure of atom was unknown. Nobody knew the structure of atom. But one thing that every scientist knew, that atom has positive and negative charges in it, and as a whole, atom is neutral. The only thing which was left unknown is the arrangement of positive and negative charge in the atom. So this experiment was to know the arrangement of positive and negative charge in an atom, right? Okay, so what was the logic? Rutherford knew that the alpha particle is positively charged, and we all know that the positive charge is repelled by another positive charge and attracted by a negative charge. So since gold is malleable and ductile, so we can make very thin sheets of gold, and that thin sheet is called foil, like the aluminium foil that we used at our homes. So this was gold foil, very thin sheet of gold having a thickness of not more than 1000 atomic layers. 1000 atomic layer का thickness था is gold foil ka. What is the meaning of this? So if you take this and you observe this with the help of a very powerful microscope, you will see that from this end to this end, right across the diameter of this stylus, you can see there are trillions and trillions of atomic layers, because atom is very small. So in the length which is equal to the diameter of this stylus, you will get trillions and trillion layers of atoms. But this gold foil was very thin, not more than 1000 atomic layers, like 1 atom, 2 atom, 3 atom, 4 atom, 5 atom. If you see this with a powerful microscope, then almost 1000 atomic layer thick was this gold foil, right? So which is very thin as compared to other material. So alpha particle, we needed, I was not there at that time, the Rutherford needed a very thin foil, because when the alpha particle passes through the gold foil, it will interact with the positive and negative charge which is present in the atom, right? So that interaction would not be possible if the thickness is very large, right? If the thickness is like millions and trillions of layers of atoms, then what the alpha particle will do, it will enter the gold foil, and it will undergo so many interactions that it won't be possible for the alpha particle to come out from the other side. So if the alpha particle is not coming out from the other side, we will not be able to observe the path of the alpha particle. And that was the whole story. He wanted to observe the path of the alpha particle when the alpha particle comes out of the gold foil. Only by observing that path, he will get to know the position of positive and negative charge in an atom. So a gold foil, which is gold, is the most malleable and ductile element. So that's why he used the gold foil and bombarded positively charged alpha particles, right? So what was the observation? What happened in the experiment? What were the observations of the experiment? So he saw that most of the alpha particles went straight through the gold foil. Most of the alpha particles went straight through the gold foil. So which was very shocking. Most of means about 90% of the alpha particles, they went straight through the gold foil. There was no deflection in the path of the alpha particles when the alpha particles were observed on the other side of the gold foil. So in almost 90% of the alpha particles, there was no deflection, which means, which is written there in the Rutherford's atomic model. So he concluded that since most of the alpha particles went straight through the gold foil, that means most of the space in an atom is empty. Most of the space in an atom is empty. Maximum space atom के अंदर खाली है बिल्कुल, right? Okay, so and very few alpha particles deflected by smaller angles, and few alpha particles, very few alpha particles deflected by larger angles, and very few alpha particles went straight back in their original paths like this. Suppose this is the atom. So what Rutherford concluded, that after seeing the deflections of the alpha particles when they have passed through the gold foil, he concluded that most of the space in the atom is empty. And since alpha particles are suffering very less deviation, and positive charge gets repelled by the positive charge. So since alpha particle is positively charged, so the position of positive charge in the atom is such that the positive charge is concentrated in a very small region. If the positive charge was distributed in the entire atom, then obviously maximum alpha particles will suffer deflections in some angle or the other, at some angle or the other, right? But since maximum alpha particles went straight through the gold foil, that means most of the space is empty and the positive charge is concentrated in a very small region. Rutherford gave the name nucleus to that small region because cell, human cell or animal cell, living cell was already discovered at that time, and the central portion of the cell where the nuclear material is present is called the nucleus. And Rutherford used the same term for the nucleus of the atom also, right? So what he said, that since this positive charge is concentrated in a very small region, so most of the alpha particles, because most of the space in the atom is empty, so most of the alpha particles went straight, most of the alpha particles went straight because like this alpha particle is far away from the nucleus, so there was no repulsive force of the nucleus on this alpha particle, so it went straight. So alpha particle, since this nucleus is very small, so there were very few alpha particles which passed near to this nucleus, and they suffered small deflections in their path. Like this particle will go like this, and this particle will suffer more deflection because this is much nearer, and now this particle will be deflected by an angle of 180 degree, because this is the particle which is coming along the central line of the nucleus, so it will suffer maximum repulsion, right? It will experience maximum repulsion, and repulsion is very high. So it will, when it is coming towards the nucleus, the kinetic energy of the particle will decrease, and finally the kinetic energy of this particle, this alpha particle, will become zero, and it will retrace its path and go back along the same line, right? It will go back along the same line. I've shown the path like this just to, because if I would have shown this along the same line like this, so it will be difficult for you to see. So I have made two separate lines like this, like you take a U-turn, but this went along the same line. This particle went back along the same line. So this particle will suffer this type of deflection. This particle will suffer this deflection, and this particle will not suffer any deflection, right? So this is not the size of the atom. This is not made to the scale. Just imagine that the size of the atom is this much, right? Size of the atom is or more than this. In fact, the size of the atom is 1 lakh times larger than the size of the nucleus. So there is so much space in an atom which is empty and which is far away from the nucleus. So all the alpha particles which went through that part of the atom, they went straight, right? So more than 90% of the alpha particles went straight through the atom. So this was the observation, and based on this observation, Rutherford gave a very important model which is called Rutherford's atomic model. But let us understand one thing which is called the deflecting angle. This angle, this was the original path of the alpha particle, and this angle, this is the angle of deviation, right? Or it is also called the scattering angle, right? This theta, this is called the scattering angle. So Rutherford plotted a graph between the scattering angle and the number of particles which scattered at that angle. What is the meaning of this statement? So he made a graph between scattering angle, value of scattering angle is plotted on x-axis, and the value of number of particles is plotted on y-axis. So the shape of the graph came out to be this, which says that more the scattering angle, less is the number of particles which scattered at that angle. Let us say this is the scattering angle of 30 degree and this is the scattering angle of 60 degree. So at 30 degree there were more particles which scattered at 30 degree, and if the angle is more, the number of particles which scattered at that angle become less, because those particles suffered more deflections which were nearer to the nucleus, and since nucleus is very small, so there were very few particles which are near to the nucleus, right? And okay, based on all this, first Rutherford calculated the size of the nucleus, right? How he calculated the size of the nucleus? For this we have to understand a term which is called the distance of closest approach. Suppose this is the atom and this is the nucleus, right? This is the nucleus, and let us take this alpha particle which is coming along this line, which is the central line of the nucleus. This line, this is the central line of the nucleus, and the alpha particle which is coming along this line will suffer maximum deviation, that is a deviation of 180 degree, right? This particle, when it is coming along this line, it will slow down, and again slow down, and eventually at this point the kinetic energy of this particle will become zero, and it will go back along the same line. So this distance, which is the distance between the center of the nucleus and the point from where the alpha particle turns back, right? It is the point where the kinetic energy of the alpha particle became zero. This distance is called the distance of closest approach, right? Because alpha particle जो है वो इतना ही पास आ सकता है न्यूक्लियस के, इससे और पास नहीं जा सकता. So Rutherford concluded that obviously the radius of the nucleus should be more than this distance. Obviously the alpha particle will not go into the nucleus and then comes back. Obviously when the particle gets deflected back, then the distance between that point and the center of the nucleus will be more than the radius of the nucleus. So he calculated this distance, and based on this distance he estimated the size of the nucleus. So how he calculated this distance? He said that let the kinetic energy of the alpha particle is half mv square, which was known, that is 5.5 mega electron volt, and this is Ze and this is 2e, right? Because how many protons are there in the gold nucleus? 79 protons. But this was not known at that time, but he knew the charge of the entire gold nucleus. So this Ze means Z is 79. Z means atomic number, and E is 1.6 into 10 raised to the minus 19, which is the charge of the proton, right? So Ze is the charge on nucleus and 2e is the charge on alpha particle. So the alpha particle turns back at that point where the entire kinetic energy of the alpha particle gets converted into the potential energy of this system of alpha particle and gold nucleus. So we will write K, that is 1 upon 4 pi epsilon naught 2e into Ze divided by r square, right? And this is r naught in this case, and using this equation he calculated the value of this is I use the formula of force instead of energy. We have to use the formula of the potential energy and not the Coulombic force, because the kinetic energy converts into potential energy. So this is what? This is the Ke of the alpha particle, right? So this is Ke alpha. So R naught equal to this, and let's put the value of each and every thing. 9 into 10 raised to power 9 into 2 into Z, that is 79, into E, which is 1.6 into 10 raised to power minus 19 ka square divided by Ke of alpha, which is 5.5 mega electron volt. And if you convert mega electron volt into joule, you will get this. So this is going to be, this came out approximately in the order of 10 raised to power minus 15 meter. So which was enough to give the estimation of the size of the nucleus. So the order of the size of the nucleus is 10 raised to power minus 15 meter, which is called 1 femtometer or 1 Fermi, represented by Fm. So 1 Fm is 10 raised to power minus 15 meter, right? And the size of the atom is 10 raised to power minus 10 meter, which means the size of atom, the radius of the atom is 1 lakh times more than the radius of the nucleus. So based on all this, Rutherford gave his atomic model, which is Rutherford's model of atom. We have discussed each and everything about that. Just we will read out the postulates of Rutherford's model of atom. An atom consists of a small and massive central core in which the entire positive charge and almost the whole mass of the atom are concentrated. Since alpha particle also has some mass, so if there was some mass in the empty space around the nucleus, even then the alpha particles would have suffered collisions with that mass. So based on this, that most of the alpha particle went straight through the atom, it means that the entire mass is also concentrated in a very small region at the center. The size of the nucleus is very small as compared to the size of the atom. This is S. The nucleus is surrounded by a suitable number of electrons. So that, now what about the negative charge? Since the positive charge is present in a very small region, so what about the negative charge? This was proved later, but Rutherford gave a postulate about the negative charge also, which says that negative charge is carried by the electrons which are very small. Obviously, if they were large, alpha particle would have suffered collisions with them also. So electrons are very small, negatively charged particles which revolve around the nucleus, right? The nucleus is surrounded by a number of electrons so that their total negative charge is equal to the total positive charge on the nucleus, and the atom as a whole is electrically neutral. The electrons revolve around the nucleus in various orbits just as planets revolve around the sun. The centripetal force required for their revolution is provided by the electrostatic attraction between the electrons and the nucleus. Why the electrons are revolving around the nucleus? Obviously, a centripetal force is needed for any body to go in a circle. So if electrons are moving around the nucleus in circular paths, then obviously a centripetal force is provided by some other force, and that other force is the electrostatic force, because electron is negatively charged and nucleus is positively charged. So the electrostatic force of attraction between them is providing them the necessary centripetal force for the circular motion. And limitations of Rutherford's model of an atom. The major limitation of Rutherford's model was the stability of the atom. Rutherford could not explain the stability of the atom because according to electromagnetism, the electromagnetic theory, when a charged particle accelerates, obviously if electrons are moving in circle, and circular motion is always an accelerated motion. So according to Rutherford, electrons are moving in circles, so they are basically accelerating. So when the charge is accelerating, it starts emitting electromagnetic radiations, which is a form of energy. So obviously, if the electron is continuously emitting energy, then the energy of electron will definitely decrease, and the hold of the nucleus will increase on the electron, due to which the electron should follow a spiral path, and ultimately it should go and hit the nucleus, right? The path of the electron should not be circular because it is continuously losing energy, and so it should follow a spiral path and it will hit the nucleus and the atom will not exist. Each and every atom of this universe would collapse if the Rutherford's atomic model is true. So why the atoms are existing and this is not happening? Rutherford could not explain this. And so the Rutherford's atomic model was rejected, but it was very important model. The entire picture of atom that is there in our brains is due to this model only. So after this, the Bohr theory came and he explained this on the basis of his theory, which is Bohr's theory of hydrogen atom, and we will talk about that theory in the next video. Till then, all the